This is Dr. Trussell, and I'm going to be going through a quick overview of Chapter 10 of Giancola's textbook, Program Evaluation, Embedding Evaluation into Program Design and Development. Chapter 10 is the second part of our implementation. We started discussing implementation back in Chapter 9. And there we were collecting our data and organizing our data, and now we analyze our data. So there are multiple types of data analysis or tools that we can use to analyze our data. One of those, especially when we're dealing with quantitative data, is descriptive statistics. So these are statistics that are used to summarize our quantitative data. A number that summarizes our data in some meaningful way, describes or summarizes or represents concisely a set of data. It's especially useful when we're dealing with large quantities of information. If we just have a real small data set, if we have maybe 5 participants that we've interviewed, it might be easy to sort of look over the data and eyeball it and come to some conclusions. But if we have 5,000, now we need some other tools in our toolbox. So descriptive statistics is usually a good place to start. Most folks start here when it comes to qualitative data. It's just some quick, succinct descriptions or summaries of the data. So what are descriptive statistics? Well, they're things you've probably heard of in a stats class before, or a research methods class before. A mean, which is the average, a standard deviation, which is how much the data varies around the average. You can use software to calculate these things, and then it's important to understand the interpretation of them. So when you're interpreting your mean and your standard deviation, it's pretty simple to interpret what the mean means. It's just the average value, right? We all, most of us by now are used to what an average means, but standard deviation might be a little less intuitive. Still pretty straightforward though. So it just tells us it's a measure of how spread out your data are around that mean. So if you think about a couple of different data sets, one where every value is 5 and the other where half your values are 0 and half your values are 10. Both of those data sets are going to have an average value of 5, and your standard deviation then would be useful to note that that second data set has a much bigger spread of the numbers, that those numbers are on the extremes, 1 and 10, versus the first data set where all the numbers are close to the average, or actually equal to the average in that example I just gave. So that's sort of what the standard deviation does for you, is it lets you know how, now that you have your average, how spread out are the data relative to that average. The median gives you the midpoint of your data set. If you put them all in order, where's the middle one? That's your median. The mode gives you the value with the highest number of occurrences. It's the most likely score on a test, for example, the score that most people score, or that has the most students who score it, I guess I should say. Not necessarily the same thing as saying most students score that, but it's the score that has the highest number of occurrences among all the possible scores. The range is the difference between their highest value and your lowest value, and variation is another way of looking at how spread out data are. It's really just the square of the standard deviation. And some people, and for some purposes, will use a variation together with a standard deviation or instead of the standard deviation. A frequency distribution is another type of summary statistic or descriptive statistic for interpretation. It's a lot of times used in categorical data. When you don't have numbers to calculate an average, you may instead show a frequency distribution, which is sort of a graph or it could be a table or a chart that just shows you the count of groups in the data. So you might have, and you can use this for numerical data as well as categorical. You might have collected data on eye color, for example, and so you might create a frequency distribution that shows how many of your respondents have green, blue, or brown eyes. That would be a frequency distribution. It doesn't make sense to try to find an average of colors, right? But sometimes a frequency distribution is useful when you do have numerical data. You can find the average, but the average isn't necessarily a useful number because maybe you have a really high standard deviation. And when you have a really high standard deviation, that means your mean or your average isn't a very useful number for describing the data. Because, yeah, you can find the average, but that high standard deviation tells you that the values are so spread out, so varied from that average, that the average may not be the best way to try to summarize your data. And so in those sort of situations, you still might use a frequency distribution, even with numerical data, to show, for example, how many values fall between 1 and 2, how many values fall between 3 and 4, how many values fall between 4 and 5, or 5 and 6, right? So you can give a sort of a snapshot of your data in that way when the mean, for example, doesn't make sense as a descriptor of the data. Another quantitative data descriptor is correlation. Some people don't consider this to be a descriptive statistic, but it really, in many senses, is, because it describes the relationship between two variables. It describes the strength and the direction of a relationship between two variables. So if you've collected eye color and you've also collected hair color, then you might have a correlation value that tells how strongly eye color and hair color go together, right? A correlation coefficient, you may remember from statistics, ranges between +1 and -1, and the closer it is to 1 or -1, the stronger that relationship. And the sign, positive or negative, tells you whether those two variables move in the same direction or move in opposite directions with each other. So those are descriptive statistics, ways to just sort of quickly get a snapshot of our data. Then we also have inferential statistics. Some people, like I said, consider correlation to be inferential, and we'll talk about that in a second. But inferential statistic is a number that's calculated based on a data set and can be used to draw conclusions about a greater population that your data set is supposed to represent. It helps you to draw conclusions or go beyond simply describing the data you've collected. But oftentimes your goal in doing something like an evaluation is to be able to describe a broader population, or describe relationships that may exist in a broader population. So an inferential statistic allows you to do that. Inferential statistics, again, correlation is the correlation coefficient itself is descriptive, but we can use the correlation coefficient together with other types of tools to make it a little more inferential. So a hypothesis test, for example, will test a null hypothesis versus an alternative. So the null hypothesis says there's no relationship between these two variables, between someone's, I don't know, what's a good example? There's no relationship between someone's participation in our program and their reading score at the end of the program, right? If we're talking about a reading intervention in a school or something, right? So our null hypothesis is that there's no relationship. Our program didn't cause any difference in reading. Our alternative hypothesis then, or our alternate hypothesis then, is that there is a significant relationship between the two, between participation in our program and an outcome. So we can test that. We can test that hypothesis. When we do, we get a p-value. Again, I'm just scratching the surface of this, because if you want the details, you can take a stats class. There actually are a lot more details in this chapter too that you can read, but the real details will be in a statistics class. So a p-value out of a hypothesis test tells you the probability that your null hypothesis is true. How probable is it that you collected all the data you've collected and that data are true, and at the same time there's no relationship between the two variables you're testing. So given the data you've collected, the p-value says the probability that the null hypothesis is true, the probability that we have no relationship. And typically, if we're looking at the relationship between our program and one of our goals or our desired outcomes, we'd like for our p-value to be pretty small. We want there to be a low probability that there's no relationship between our program and the outcome that we're looking for. But we'll set a significance level or an alpha that tells us the probability of what's called a type 1 error. So a type 1 error was what happens when you reject your null hypothesis, but actually it was true. So we'll set this significance level as essentially the level of confidence we want to have in our findings, and we'll compare that p-value to our alpha to decide whether or not we believe the null hypothesis is true. And again, typically if we're looking at the relationship between a program and the intended outcomes of that program, we would like to find that the null hypothesis is not true. We'd like to reject our null. But I should pause here and say a good researcher, a good evaluator, is not looking for the answers they want. You're looking for the answers that are truly in the data. The data will tell you whether there's a relationship or not, and your ethical obligation is to report what you found. So yeah, we'd really like to say that our programs are making the difference that we designed them to make. But if the data say something otherwise, if we can't reject our null hypothesis, then it's our responsibility as a researcher to report that as we have found it. So correlation statistics themselves are descriptive, but when we pair them with a hypothesis test with a p-value, we can now infer how likely our sample results reflect our actual population. So the correlation tells us that there's this relationship here, and the p-value can help us understand how likely that relationship is to actually exist in the true population, not just in our little sample of data. Also important to note, correlation is not causation. It means that the two variables are related to each other in some way. It does not mean that one variable causes the other. It could mean A causes B, it could mean B causes A, or it could mean some other thing that we're not even accounting for is causing both of them. So we really don't know anything from just a correlation coefficient. All we know is that there's a relationship, and what the direction of that relationship and strength of that relationship are. We do not know that that relationship is causal, that one thing is causing the other. So that's correlation. Another inferential test is a t-test. T-tests can be paired and independent. It's a statistical method that we use to determine if the difference between two means is significant. So you may have two groups, like our program group and our control or comparison group that we discussed in program design, and you then measure the mean test scores for each of the two groups, and you want to know whether the difference between those two means is statistically significant. You can almost always expect there will be a difference between the two means. It would be really, really rare, nearly impossible to have two groups and get averages that are exactly the same, right? But what we'd like to know is, based on our program design and the number of participants and other factors, is that difference that we're seeing between the means representative of, or is it big enough or strong enough that it tells us that there's very likely to be truly a difference in outcomes for the two groups. That's what a t-test does for us. Helps us determine whether the difference between those two means is actually a significant difference, a true difference. And then another a popular inferential statistic, because it does allow us to do some work with causality, is regression or multiple regression. It allows us to examine relationships between one or more variables, not just two. We could use more than two, and another variable. And it lets us determine how predictive one or more variables are of a certain outcome. So this using regression, it's not a slam dunk on causality, but it helps us get more to the idea of causality. How much does one variable predict another variable? So the number of days that you showed up for the after-school reading program, is that related to your increase in your reading score, right? So we can measure the prediction. Does showing up more often predict a bigger increase in reading scores? That sort of thing is what regression allows us to do. And it would allow us to put in more things than just showing up. It might, okay, so what was maybe your reading score prior to the beginning of the program? And also how many times you showed up for the program. We could put both of those into the same model and look at how each of those predicts your reading score at the end of the program, just as an example. So I'm not going to go through all the things on this slide. I encourage you to pause the video here, though, and look through these really nice examples of different descriptive and inferential statistics. So that's quantitative data. Those are ways that we analyze numbers and quantitative things. What about qualitative data? What about things like our interviews and our focus groups, or when we look at those existing program documents and things like that? How do we analyze that? You can't find an average from among folks' replies to an interview question. So what do we do there? And we have really 3 steps in the process of analyzing qualitative data. The first one of those steps is coding. Codes are basically labels that assign meaning to our data. So you go back through your transcript of your interview or your focus group, and you apply codes to chunks of your data. You do this in order to categorize similar data. So it's easier later to find and cluster your different segments that are related to each other, and themes begin to emerge from the things that you learned in your interviews or focus groups or other types of qualitative data. It lets us condense and retrieve the material. It's easier to go back and find things, sort through our the responses that we receive to interview questions, for example. So it's a way of labeling a theme, labeling a chunk of code for what sort of is happening in that chunk of code. Maybe that'll become more clear when we look at different types of coding. So when we develop our codes, there are a couple of different types of codes we could develop. Deductive codes are pre-specified. We develop those from our evaluation questions prior to analyzing our data. It's often referred to as a start list. It's derived from our conceptual framework, our evaluation questions, our hypotheses, our key variables. They're maybe the things that we know that we're looking for in our responses. We go ahead and we already have those codes, and so we're going to take chunks from our transcripts and drag them under those codes that we've already created. Inductive codes, on the other hand, are codes that we didn't necessarily pre-specify, but they emerge during our data collection or analysis. When we start to notice trends or themes coming out in what is being said by all our participants, in participant responses, we may notice, hey, this was something that a lot of them mentioned. I wasn't necessarily expecting it in the beginning, so it's not one of my deductive codes, but it seems to be a theme. It's important enough to code it as its own thing. And sort of as I just described, a lot of times we use a combination of deductive and inductive codes. So we have a start list. We start with the codes we're sort of already looking for, we sort of already expect, but then as we collect our data or analyze our data, we see new factors or themes come out that we will then add to our code list. So we have deductive themes versus codes versus inductive codes, which really just describes when we decide on the code, right? Then we have types of codes that describe what the codes sort of do. So a descriptive code summarizes data in a word or a phrase. You might have a list of topics used to categorize data or note patterns in your data. And I do encourage you with each of these to go back and look in the textbook. There are some really great examples of each of these types of codes that make it clearer what we're talking about here. So when I say a code that summarizes data, seeing an example of that makes that clearer. So that's a descriptive code, summarizes data. An in vivo code just pulls a word or a phrase from participant language, usually put it in quotation marks as a code, and use that then to emphasize a participant's voice. A lot of times it's useful when you're first starting out learning how to code and you're not sure what categories or what summary words to use yourself. Just pull some words from what the participants said and create some categories from that. And that's an in vivo code. A process code labels and indexes observable or conceptual action in the data. They can also apply to actions that emerge, change, occur in particular certain sequences. So again, go look at these examples in the text to further understand what these different types of codes are. And simultaneous coding is when you've got a chunk of data or multiple chunks of data that you apply more than one code to. You've got more than one of your overarching categories or themes is represented in a couple of paragraphs of your transcript maybe. And that's fine. You just put more than one code there. It's important when we're talking about coding, similar to some of the things that we talked about with organizing our data and saving files and things like that when we were saving our transcripts. It's important when we're coding to be sure that all the researchers on a team understand the codes and apply them consistently so that our data analysis is consistent and organized in a way that we can actually pull themes from it. So step one is coding. We're going to chunk our data up, our qualitative data. We want to put it into buckets based on themes that we see emerge in our data. Step two is synthesis. We want to take that data that we've coded and we've chunked, and we want to start to put it together in a way that themes will start to emerge. So a narrative description is where you just write a little passage that elaborates on a code. You communicate with your reader what you're finding in this coded section. What is it that I mean by this code, and what is it that people were saying here that made this an important code to sort of set apart on its own? So a narrative description. You also can use a matrix. There's an example down here on the slide of a matrix that can help to identify patterns in the data. This particular matrix shows which trainees observed family mentors and children in different settings, right? So you can use a matrix to identify, to synthesize your data, to help you understand your data better. Next, another visual way of understanding or synthesizing your data is with a network display. Excuse me. So a network display, there's an example shown here. It's where you draw the relationships that you're seeing in your data here. So you illustrate a process. It's a map with lines and arrows that indicates how people, components, or actions connect and flow. And then this may be the simplest, at least for me. This would be the way that I work a lot of times, is with just jotting. You're writing little short comments on your chunks of data as you're reading through raw interview data or field notes or reviewing documents. You may just jot down little things that you noticed, your personal reactions, notes to ask, hey, I should ask more questions about this in the future. A critique, we probably should have done that a little differently. Whatever sort of stands out to you as you're reading through, you just jot that down. That's a jotting. All of these are ways to synthesize your data, to start to understand it. You've collected it, you've organized it, you've coded it, which is sort of an extension of that organization. We're sticking common things together. And now we want to start talking about or start developing what it is we're seeing emerge. So the last step, we've got coding and then synthesis, and the last step is to make your assertions. We've got our themes that are important findings in your data based on your codes, a generalization of your coded output, memos, which are your thoughts or ideas that represent meaning derived from your codes and themes. So my themes are, hey, here are the things that are emerging from my coded data, and my memos are more like, what do I think about that, right? So my thoughts from my derived meanings from those. You want to write all those things down. And then finally, you want to be able to make an assertion. An assertion is a statement made about the themes found in your data. And it's helpful if there's one strong assertion with multiple quotes to support that assertion. There's again some great examples in the textbook of what an assertion might look like, but it could just be something like participants seem satisfied with the following feature of our program, right? I don't know. That's an assertion. And then you've got your quotes from within your interview transcripts that support that assertion, where different participants said things about their satisfaction, for example. So this is sort of what we're aiming for in our quantitative data. We want to be able to have descriptions of our data, and we want to be able to know whether our data can be generalized to larger populations. We want those numbers and those tests of hypotheses and things like that. With our qualitative data, we really want to be able to describe the themes that are appearing in throughout our different interviews or focus groups or documents that we've collected. And there are these additional types of qualitative data. It's not all interviews and focus groups. We touched on this in previous chapters. But even with documents, field notes, literature, those types of things, we'll analyze them in a very similar way. We can code them and synthesize them and make assertions in the same way. But the assertions are really what we want from our data analysis with qualitative data. What themes do we see emerging? What can we assert? What can we say with pretty good confidence about the data that we've collected? So the last piece of this chapter, which I'm not going to go through here, but it's useful. It's certainly helpful, and I encourage you to go read it. Just talks about what to do about unanticipated things that may come up while you are implementing your program evaluation. your program changes all of a sudden, and now what? Your evaluation is messed up, or not consistent from the beginning to the end. You've got strained relationships with your clients. They don't trust you, or you're having trouble getting through to them to do your evaluation. You get negative findings. You find that the program is doing harm, for example. What do you do about that? Or null findings. You find the program's not doing anything. It's not accomplishing, there are no outcomes associated with the program. You have insufficient data or barriers to obtaining data. So you can't really you don't really have anything that you can assert at the end of your data collection because you don't have enough data for it. Your client requests raw data from you or report revisions, or something that might to you be an unethical, or it might be unethical for you to respond positively to that request or to grant that request. What do you do when those things happen? Or when a client disagrees with your findings? You have, to the best of your ability, reported what the data show, and your client respectfully or disrespectfully disagrees with you. What do you do about that? So this part of the textbook offers some really great advice from folks who are, from your textbook author as well as her team, who are really experienced in program evaluation. And if this is at all an area that you may go into, or if you plan to be in a position where you are managing a program or part of a program that may be evaluated, these are really great tips and suggestions to read through and sort of keep in mind for when these unexpected things happen.